All right, so what we're going to do now is the first part A was just trying to explain the nuts and bolts of what these next chapters are all about, and to try to give you just an intuitive feel for what it means to integrate, what it means to have an antiderivative. What we're going to do right now is practice just taking some antiderivatives, and remember that the only rule that we have to work with for the most part is just this power rule for integration. So we're going to practice a little bit with that. Most importantly, we're going to practice being able to rewrite a function so that you can use this power rule. Then on the last part, we're actually going to start to see how some applications and how this can be beneficial. Okay, so let's start with the most important part, which is the ability to rewrite a function. Right? You give me two calculus students, and one is working extremely hard to arrive at their answer, and the other one, it just seems to be just breezing through it. 9 out of 10 times, it has nothing to do with IQ. It's just one notice that you could rewrite this thing and make it a whole lot simpler. So let me see if I can show you what I'm talking about. So if you want to integrate, starting with part A, if you want to integrate 1 over x cubed, well, if I just think of 1 over x cubed as x to the power of -3, then I can use my power rule, right? Does that make sense? I can just say, okay, well, let's let n equal -3. And when I proceed to integrate, this is going to be x to the power of -3 plus 1 over -3 plus 1 plus c. Okay? Now, I don't have a whole lot of room here, so I'm positive that you can clean that up and get, that would be x to the power of -2 over -2. So let me continue with the rewrite phase. So again, you can think about the square root of x as x to the power of 1/2. And now, assuming that a student noticed that, they can just, again, start to apply their power rule, where now n is equal to 1/2. So this ends up being x to the power of 1/2 plus 1 over 1/2 plus 1 plus c. All right, so again, half plus 1 is 3/2. So that ends up being x to the 3/2 over 3/2. Okay. Now, you can look back on the previous video where I gave you some integration formulas. And I've already given in lecture, I gave you the proof for why the derivative of, say, sine is cosine. But we're integrating, right? So we should think about how is it that, and I'll tell you what I'll do. I'll scroll back just so you can see it here. But the first thing I'm going to do is rewrite this as 2 integral of sine of x dx. Again, see how I'm bringing the 2 out front. Now I'm going to scroll back to that list of formulas, and let's go ahead and find the integral for sine of x, right? And what we see is the integral of the antiderivative of sine of x is just negative cosine of x plus c. So we end up with 2 times negative cosine of x plus c. All right, so really, really quickly, the treatment of that, actually, hold on for just a second. Let me move this down here. So I just want to say something really quickly about how different textbooks treat C. So the way that author would treat C in this case is they would just simply write this as negative cosine of x plus c. I'm sorry, negative 2 cosine of x plus c. Now, I know that for many of you, so let me go ahead and write that as, so negative 2 cosine of x plus c. I know that for many of you, you would think about that as being 2c, right? 2 times c is 2c. I just want you to understand that the treatment of that, since you don't know what c is, it's quite irrelevant to talk about double c. So this is the way that I will be writing my answers. But I won't fault you if you were to ever distribute a 2 to the constant of integration. That's, of course, not a problem at all. Now, for this next example, let's take a look at it. So we want to integrate x plus 1 over the square root of x. And again, I have 2 calculus students, and one of them is just working so hard to integrate this, and the other one, hey, they just noticed, wait a minute, I can rewrite this as x over the square root of x plus 1 over the square root of x. Right? That ability to just be able to rewrite the integrand is going to make this so much easier. So, okay, all I'm gonna do right now is, well, I'll tell you what, let me get rid of this picture here because I'll bring it back when we need it. So let's go ahead and go a little bit farther. So that is going to be x over, instead of having the square root of x, we could have x to the 1/2. And that's going to be plus 1 over x to the 1/2. Okay, well, what is x divided by, I'm going to erase this in just a second, but what is x divided by x to the power of 1/2? Well, like bases, right? So we subtract exponents. So that is x to the power of 1 minus 1/2. So if you have $1 and you take away 50 cents, what do you have? You have 50 cents. So you end up with x to the 1/2. And finally, if I have, I'm going to erase that part. Finally, if I have 1 over x to the 1/2, of course, I can rewrite that as just x to the power of negative 1/2. So this becomes plus x to the power of negative 1/2. All right, now what I've shown you, that ability to rewrite, is the hardest part of this problem, because now that we're here, this is simple. We're going to actually integrate this piece by piece. So we're going to integrate x to the 1/2 with respect to x, and then we're going to integrate x to the negative 1/2 with respect to x, and then we're simply going to add the results. Ready? So let's start to pick up the pace a little bit. So in this case, n is equal to 1/2. In this case, n is equal to negative 1/2. So let's apply our power rule. So this is going to be x to the 1/2 plus 1 over 1/2 plus 1 plus, and this is going to be x to the power of negative 1/2 plus 1 over negative 1/2 plus 1. Now that will be the last time I will write this step out here. Henceforward, I'm just going to assume that you knew that I added 1. Okay? So the result is x to the, and that's plus c. So let me go ahead and write plus c here in blue. And the result ends up being x to the 3/2 over 3/2 plus x to the 1/2 over 1/2 plus c. Now, as of right now, by the way, this is a very sloppy product for you to give to your client, but it is the right answer. Okay, so the cleaning up part that we're about to do has true value in that normally we don't integrate just to integrate, right? Normally there's something we want to do with our antiderivative, like set it equal to 0, etc. So what I want to go ahead and do is first I'm going to erase all the information above. And then I'm going to go ahead and rewrite where I'm going to put a star here, and put a star here. I'm going to rewrite where we left off, x to the 3/2 over 3/2 plus x to the 1/2 over 1/2 plus c. This is, again, let's take a little bit more pride in our work. This is quite sloppy. So watch what I'm going to do here. So to divide by 2, right? Dividing by 2 is to multiply by 1. Sorry. To divide by 2 is to multiply by 1/2, right? So to divide by 3/2 is to multiply by 2/3. Okay? So this is really 2/3 x to the 3/2. To divide by 1/2 is to multiply by 2. To divide by 2 is to multiply by 1/2. So this is plus 2x to the 1/2 plus c. All right, and normally, if you were to say look up the answer in the back of a textbook, normally what they would have done is, of course, they would have factored. They would have factored out, say, 2/3 x to the 1/2, and what would be left would be the x plus 3. So normally they probably would write that as the square root of x instead of x to the 1/2. So for now, I'm good if you can get me to here. Don't leave any negative exponents. Let's not be too sloppy, but but I'm good if you can get to what I've boxed in right there. All right, just a couple more. You can always pause this video and try it on your own. In fact, I'm going to erase part B. We've already done something very similar to. No. I am gonna change my mind because that's what I do. Let's go ahead and write part B one more time. I'm going to integrate x plus 2 with respect to x. I chose these two particular problems, even though they're very easy. For some reason, they elude students now and again. So first, we want to integrate, and you're thinking, wait a minute, Professor, what the heck is even in there? Well, the way you want to think about that is when you see it written as the following, integrate with respect to dx, you want to think about that as having a 1 in here inside as an integrand. Okay? I know where you're like, where'd the 1 appear? Where is it? It's just, that's the way you want to think about this. So in this case, the derivative of what is 1? Right? What did I just say? The derivative of what equals 1? The derivative of x with respect to x is 1. So this ends up being x plus c. You could apply the power rule if you really wanted to. I'm not going to go into much detail here, but if you just thought about that as 1 x to the power of 0, you could then apply your power rule, if that helps. finally, very last one here. If you integrate, well, first off, we can set this up as the integral of x with respect to x plus the integral of 2 with respect to x. And now let's go ahead and answer this. I'm going to start with the, we know it's plus c, but if I integrate 2 dx, that's just going to be 2x. That part's easy. I want to make sure you understand. Yeah, actually, yeah. So everything else is good, and of course, in this case, the n would equal 1. So when you this would be n to the x to the n plus 1 over n plus 1 ends up being x squared over 2, or 1/2 of x squared. All right, so a few others. I'm not going to go through and integrate each of these into each of these below. I just want to show you how you would rewrite them. Okay, so in this case, let's start with sine of x over cosine squared of x. Well, right now, let's think about our definitions of sine of x and cosine squared. So notice how what I'm going to do is I'm going to write this as sine of x over cosine of x times 1 over cosine of x. Right? Because cosine times cosine is cosine squared, and sine times 1 is just sine. So that's, of course, that's perfectly legal for me to rewrite that. And now, what is my definition of sine over cosine? Well, that's just tangent, tan of x. And what is my definition of 1 over cosine? Well, that's secant x. So at this stage, if you want to integrate secant tan or tan secant, we're going to have to go back to our integration rules. And what you see is when you have a situation where you're integrating secant tangent as your integrand, then the result is just secant of x plus c. So the result in this case is simply going to be secant of x, secant x plus c. Okay. Now, this will be the last problem, and I'm not even going to go through and solve each one, right? You do need some practice. All I want to do is make sure you know how to rewrite each of these integrands. That's the only thing that I care about right now. So let's start with part A. So of course, 2 over the square root of x, that's just 2 over x to the 1/2, which is the same thing as 2x to the negative 1/2, right? Makes perfect sense. Now, for part B, I would probably go through and FOIL that. So I would write that as, I would go through and take t squared plus 1 times t squared plus 1, so that I can rewrite that integrand as t to the 4th plus 2t squared plus 1. And then I would go through and integrate that with respect to t. For part C, I would break that up as x cubed over x squared plus 3 over x squared before I integrate. And when I do, well, x cubed divided by x squared is just what? It's just x. And this would be plus 3. Now, 3 over x squared is the same thing as 3 times x to the negative 2. And finally, for part D, I would distribute. I would turn that would turn that radical, right? I would turn that radical into x to the power of 1/3. And the last step that I would do is actually distribute that radical so that you get to x to the power of 4/3 minus 4x to the power of 1/3. And that will be it for this video. The next part, the last part of this section, we'll actually see if we can do some applications and show you why this would be useful to know.